Okay, so Cast AI fairly recently published the 2026 State of Kubernetes Optimization report, and it shows GPU utilization averaging just 5%. And that's even as organizations obviously pouring money into AI infrastructure. What do you see as driving such extreme underutilization? And I guess perhaps as importantly, if not more important, is why is this going largely unnoticed?
Oh well, that's actually a great question. When we looked at it, I actually got very surprised because GPUs are very expensive, much more expensive than the same machine without GPU. So I thought people would pay attention to it and make sure that whatever they have is very well used. Um, one thing is it's not a survey; it's a real measurement of utilization. So it's a real number, is what I mean, and it's statistically relevant because we looked at this number for high-end GPUs, low-end GPUs, and it's kind of the same thing. Low-end is a little bit less used, high-end is a little bit more used, but the number is still in the low single digit. So there's a few reasons for it, and I'm going to tell you the one we think happens and why it's so low. Number one, you have to see that GPUs first they are very expensive. It's about 100 times more expensive. A machine with GPU is roughly 50 to 100 times more expensive than the same machine without GPU. So it's very expensive machines. The second thing is those uh, machines are very hard to find. And that's a true statement. Like if you want H200 or Blackwell B200 or B300, and you ask a hyperscaler, the first answer they're going to tell you is, sorry, we don't have any. And they really don't have any, meaning it's already all sold. They have a lot, but they are sold already to customers. So they're very hard to find. And usually you cannot find them, even at most neo clouds. They all sell those uh, uh, they all do future selling, meaning it's sold today for utilization in a few months' time when they get the new unit from NVIDIA. And the third thing is that those GPUs are very valuable to enterprises and to users, meaning what you do with this is incredible and has a huge economic value. Um, it's important because when you see the 5%, you say, well, okay, so it's all hype. No, it's very important. And you do create a lot of value from having those GPUs. We see this in the news, but we live this every day. And it's actually really incredible when you see a coding agent use this GPU. So what happened when you have these three things together? They're very hard to find. They're extremely expensive and they are very valuable. Well, what you have when you have these three things together, it's called the hype.
Mhm.
That's the hype. It's true. You want them because they are so valuable. So what happened is as soon as you find any as an enterprise, you are going to buy them. So the action of buying is actually disconnected from the action of needing. You're so afraid that you may miss them out that as soon as a hyperscaler come to you and say, well, I may have a few nodes of H200 tomorrow, then what do you do as an enterprise? You're going to say, yes, I want them. Of course I want them because you know how valuable that is. But it's even worse than this. The hyperscaler will come and talk to you and tell you, well, I have a few Cooper 200 coming tomorrow, but you have to tell me now because I have another 5 customers who want them. And they call you because you're probably the first on the list because you have a great, you're a great buyer for the hyperscaler. But they are going to tell you this. Well, you have to tell me now because by tomorrow they will be gone. I know because it happened to us. And by tomorrow they were gone. And there's no hard feeling. They have another 5 buyers anyway. So when you have all these things, they come to you and they say, well, I know it's very expensive, but I know it's very variable. I know you wanted them. I know they're very hard to find. What do? You buy them. Of course you do. And you buy them not just for the day. You're going to buy them for 1 year because they will not sell it to you if it's for less than 1 year, most of the time. Or 3 years in the case of neoclouds. So think about it. They come to you and they say, well, you have to decide now. And if you buy them, you have to commit for 3 years. Then you're not going to make you. The act of buying is starting to be very, very disconnected from the point of needing them. And that's why we think that's why the 5%, it's a fear of missing out. No, usually these 5% don't stay 5% very long. So you as soon as they get and they hit a cluster, meaning an application, someone will use them, but the whole cycle then start to repeat again. What we see as great use of GPU is when this 5% becomes 50%. 50% is what we tell usually customers of what great looks like. And that's what we do as a company. We optimize those machines. So we make the utilization go up to that level. It's never much higher than 50% on average because it is an average. So remember, you're stuck with them for 3 years. If you are a bank, then your customers most likely will consult their bank account and use your product during the day. But at night, we're all sleeping as human. And so fundamentally, the utilization curve for almost everything we do, whether you are driving a car or a customer of a bank, is always like this. It's low during the night, then goes up during the day, and then goes back low at night. So the maximum utilization anyway is high during the day, low during the night. That's why I say usually 50% is what good looks like. And that's what we achieve with our customers. But the measurement is very, very low before we optimize those. And I think it's a fear of missing out.
Yeah, and in terms of what's going on Kubernetes wise, the adoption rate is continuing to accelerate, but as we've discussed, CPU memory utilization going in the opposite direction. So does that tell us anything in particular as to how enterprises are actually operating Kubernetes at scale at the current time?
Yeah, that's a great question too. So my view is when you let the human manage your infra, your compute resources, then us as human, we are really, really bad at optimizing things because we'll make sure that we have enough things to run. It's our first priority is not to run out of compute. So if you're managing applications for a large enterprise, your number one goal is to make sure you have enough compute, enough computers, enough servers, enough database, enough space to run all those things. And as a human, you're probably going to look at this a few times a month. Now, how am I doing today? Why is it slow? Oh, I need to add more things. And you will probably do that a few times a month, maybe a few times a week. When you use automation or autonomous techniques, an agent that do this, the agent will actually do everything that the human may do once or twice a month, but the agent will do it every second of all the time. And that's what we see, and that's a kind of implementation we have. When you use agentic framework and you train those agents to be obsessed with utilization and obsessed with efficiency, then effectively everything that takes us a few hours or a few days is going to be fully automated in a way that the machine becomes obsessed with the result. And so when you use these agents or those automation, and I call it autonomous automation because you set it up and then it lives on its own. And it lives on its own with this obsession of efficiency, then effectively you start to see curves following each other. So the curve of what you have in your cloud account is starting to follow very, very closely the curve of what you need to run. And you do this with a very strong feedback loop and a real-time format, then you succeed to have a very, very good utilization of resources. It's interesting, Philip, when you see on the screen and you see graph on a screen and you see these two curves following each other, then us as humans say, oh yeah, that makes sense. Well, if I need 10 machines, then I will provision maybe 11 machines, a little bit above it, right? Not below, but a little bit above it. And you continue to do that all the time. And when you follow these two curves, the utilization and the amount of compute, then they follow each other very nicely. So utilization is slightly lower than the amount of compute, then you are very, very well optimized. just too much above it.
Mm.
And that's what the agent will do. It will ensure that the difference between these two curves is following themselves with that obsession that one curve is slightly above the other, never below it, then otherwise you'll have a performance hit, slightly above it, but just not too much above it. And that's what we do. That's how you see agent doing it. If you do it by hand, then you're going to have a very poor utilization. If you use automation, then you can make the automation obsessed with that difference between these two curves.
Okay, and then you describe the GPU waste as one of the most expensive inefficiencies in the modern cloud stack. Bearing in mind what you've already said, how serious is this problem for organizations building AI capabilities today? Is it just that they're acquiring the GPUs before they actually need them, or is there more going on in terms of the expensive inefficiency?
I think there are many of those things combined. So first, the action of buying is disconnected from the action of needing. You think you need, you have the fear of missing out, therefore you'll buy everything you can find. And that's understandable. Us as human, we do this in our daily life. It's going to happen the same way if a human buy GPUs. So I'm not too surprised about it. It's also the fact that when you buy them for a long time. And your utilization will not be high for a long time, just because as I described earlier, if your application is built for humans, then there is a natural drop of utilization at night because we're all sleeping at night. So we don't drive the autopilot car, we don't consult the banking app, we don't play in the stock market because we're sleeping. So you have this natural tendency. How you improve this, there are some very nice and known techniques for it. I'll give you one of them. You'll see how easy and simple it is. If you're a global bank and you have customers in Asia and customer in the US, well, when Asia is open, US is sleeping. When US is open, Asia is sleeping. So you can effectively do global load balancing of your GPU fleet worldwide. And by doing this, you start to be able to use better those machines because geographically, when you need them in one place, they are available because the other side of the world may not need them at the same time. So you can effectively do this. So that's the kind of techniques you use to increase the return of investment of what you acquire. But what I just described is very well known. It's called GPU sharing. There are many ways to do GPU sharing, time slicing. MIG, NVIDIA does have a great library of those. And that's what our agent does naturally for our customers. But these are the kind of options you have. If you don't do it this way, or you have customers only in one location, then you can't hit more than 50% on average over a week or a month of time, because the weekends will be low, because the nights will be low, and you'll have no traffic to go after it because you don't have by the nature of your business.
And the report challenges I think it's common held belief that configuration is a deployment time task. Why is it that mindset's so damaging, and what does continuous right sizing look like in practice?
Yeah, the continuous right sizing is what I mentioned earlier. When you do geographic load balancing, it is a kind of right sizing. It's a right sizing. It's a time-based right sizing where you distribute your fleet and move workloads across geography because you happen to have those assets that are idle, and so you can move workload on those assets as they are idle, so they can do something while the rest don't need them. Those are the kind of workload right sizing. It's a concept of workload right sizing, but it's very similar to other techniques you use for GPUs. In this case, it's called time slicing. There are many other techniques. So when those models are large, but you use the top line of GPUs, it's a great idea usually because the cost per watt is much lower on high-end GPUs compared to the same GPU of a few generations ago. That's great as long as you can use them effectively. So if you have a small model on a large GPU, effectively are wasting that GPU. It could do more things, but you're using a small model for it. But what you can do is load more than more than one model per GPU. And that's also some of the techniques we do. It's called MIG in that case, MIG. And you can do this automatically with very well-known techniques. We have one, but there are others that do the same thing. And so by doing this, effectively, it's a kind of workload right sizing where you slice a GPU in pieces. You can do it because the memory that the model occupy is small enough that you can insert several models in the same card. They're not all used at the same time, but then you switch from one to the other. But the switch is almost instant because everything is already loaded into memory. So memory sharing for small model on a large GPU is a really, really good idea. And if you do it this way and you fill that GPU with those models, then the cost per watt is much lower on the high-end GPU than it is on the low-end GPU. So those are the techniques that you can use for workload right sizing. By the way, those workload right sizing are no different than it is for CPUs. The big difference is GPU is more expensive, so you need to pay more attention to them. Yeah. But the idea is the same, right? You right size in real time. In this case, you slice in real time a compute asset in pieces because you can fit more workload in those assets because you slice them in pieces.
Cloud vendors, I think, fairly recently raised H200 prices by around 15%, and that's sort of going against the trend, which was falling computing costs. So just thoughts as to how engineering finance leaders should interpret this shift in the broader context of infrastructure economics. Is this a now, are we going to see that continue, or is it a blip? Just your thoughts, I suppose, as to what it signals.
Yeah, I think this is the natural consequences of the fear of missing out and the fact that you can find GPUs. So what happens when you have an asset that is that is rare and hard to find? Well, the price increase. The cloud providers trained us for many years to the idea that old generation become cheaper as new generations comes in. Right? That has been the trend for 15 years on AWS. Every year or so, you'll have a great press release from one of the hyperscalers saying, great news, this generation, we decided to drop the cost by X%, blah, blah, blah. We started to be very surprised. We're not surprised anymore, but the first time it happened, everything was in January, where one of the hyperscaler did a price increase. And usually when the price is decreasing, it's a big press release. This one was a price increase. There was no press release, and it was done on a Saturday. I understand why. I mean, those companies are very well managed, as we know, right? The hyperscalers are very well managed. But yes, the price increase. It increased because they are hard to find. They're very valuable. They're not manufactured anymore. In this case, it was the H200. They're being replaced by Blackwell now, and then Vera Rubin will come after that. But frankly, we all thought, me included, that at some point, people will get rid of those old machines to replace them by the new one. And so we all thought the same thing will be true for GPUs as it is for CPUs. And therefore, it would be a nice business to grab older generation if you know how to use them. And we were very wrong with this. We have a lot of friends at NeoClouds, and they're starting to tell us that even those A100 that started 4 or 5 years ago or 3 years ago are being renewed. And they're just not being renewed for a year. Sometimes they're being renewed for 3 years by the same customer, even though it should not make sense to continue to use them for the same workload if you can have access to the newer generation or the next generation machine. As we can't find the next generation machine, those enterprises decide to renew the old one. So self-fulfilling processes, then the hype becomes higher, the price becomes higher, it's impossible to find, they're still very expensive, you still need them, they're still very valuable, and the whole thing starts again. I think we are living that now. And by the way, it's a hype, but in this case, it's a hype for reasons that are very valid because they are really useful. because you can run agentic framework, because we know all this, right? In our daily life, like no developer do coding anymore. It's super, super cool to have access and to put LLMs on those machines. So by all means, I'm not saying, oh my God, that's bad, it's too expensive, and we have capitalist companies that are abusing it. They're not abusing anything. It's us who want that. Like I myself at Castai are always looking for machines ourselves and for our customers because we know how good they are.
Yeah.
This is
I think, sorry.
It's a hype. It's difficult because it's a hype, but it's a really valid one. It's weird to say it in the same sentence.
Yeah. I think we slightly touched on it already, but then in terms of the fact you argue that manual optimization processes just can't keep pace with the time dimension of the modern workloads we've talked about. Where do you see the biggest gaps between what teams maybe think they're optimizing and what's actually happening in their clusters? What are they surprised to find out? What are you surprised to find out when you actually dig into it?
I think it's a very hard question to answer, Philip. My view is a lot of those projects that use GPUs have a great return of investment if you know how to use them. They don't have a great return of investment at 5% utilization, but at 50 they have. I mean, the unit cost is 10x lower, but the economic value you can get from them is just enormous. I'll give you an example. We at Castai decided to we have our own coding agent. We've been using it for a few months now. It runs inside our own B200, our own GPUs. We did this because we saw that it was a great way to utilize machines that you may own or you may have in your cloud account. The good thing with this coding agent is it creates a tremendous efficiency for software engineers, for developers. By the way, we call our product Kimchi, kimchi.dev. That's how we named it. And we load open source model into those GPUs, and the result is just extraordinary. So that is where the return of investment is very, very strong. At 5%, there is none. I don't think so. I think those are failed experiments. At 20, 50% and up and above, then you will start to wonder, if you don't do it, your competition will. You'd better do it as sometimes existential threat for your business. And if you do it well, you're gonna do well yourself in as an enterprise. So that's why there is a lot of hope with this. Like, I can't wait. Whenever we see this with customer, first, when a customer connect their cluster to us, we instantly know how much utilization is all the assets almost everywhere in the cloud, and sometimes even on-prem. We have agents that discover everything. So instantly you know what is used, where they are, how much they cost, and how idle they are. Then our agents start to immediately allocate everything into the right place and start to maximize utilization of all this. And then sometimes we tell the customer, well, there is all those machines, we can actually turn them off or return them to the cloud provider, or at least use them for another project because now they become available to you. And when you do it that way, then magic happens, because your return of investment of those LLM or those AI workloads is really, really high.
Okay, and just think, given the scale of the data that Corsair analyzed, I think it was tens of thousands of clusters, as you say, was statistically significant. What patterns or surprises stood out most when you compared the AI or the machine learning workloads to more, what you call them, traditional Kubernetes workloads?
Yeah, there are some very interesting findings. One of them we saw in the previous year. We didn't write about it because we were not sure how true it was, because it was very recent. Is a very substantial use of ARM processor compared to the Intel AMD world. So in the cloud, there are two kind of machines. There is the Intel i86 type of processor, which is Intel and AMD, and there is the ARM processor, which ARM, the company, designed. Almost all mobile phones are made of it, but now the servers as well. We saw a 3.5x increase, so more than 3 times increase of ARM processor over the last 18 months. It did start at the end of 2024, but it was so early in that start that we were not sure whether it was temporary or a long-term trend. 2025 confirmed that long-term trend. It went up by 3.5x and stayed high for almost all year of 2025. So that's one trend we were surprised to see, and also glad to see, because the energy profile of ARM is much more efficient compared to usually, right? I mean, you can argue all this, but usually ARM processor is a bit more energy efficient than Intel and AMD and then i86. So that was a good news. The other news, the other surprising element is the amount of lack of resources. So almost in the beginning of this, I told you, most of the time humans will over provision. Clear for CPU is even clearer for GPUs. For many reasons. For GPU, it's fear of missing out. For CPU, it's because we do it by hand. But as human, we tend to provision more things than we need. But sometimes it's not the case. And when you under provision memory, your application reboot. You know, I'm old enough to remember this blue screen of death of Windows. Remember those things where Windows become blue and it stops working and the machine reboots? It was doing this usually because the machine would run out of memory. That was one of the reasons. Well, the same thing happened on the cloud. When you run out of memory, those containers, they are containers, right, running in Kubernetes, they actually break and restart. When that happens, you have instability. So imagine you are in your checkout application and you're buying something, get error message and you start again. Many times it's because of that. There's something that didn't work, maybe one of these containers that rebooted, so you have to restart, redo it. Sometimes it restarts on its own. It's just a bit slow. It's just because it restarted. It's surprising. We saw a high occurrence of running out of memory. So CPU we vastly over provision, and sometimes memory we don't. And you have instability. So that's the other surprising things that we saw. So it's not always about over provisioning. There are cases where we miss it.
Maybe just in finishing, just if you could give one or a couple of pieces of advice to organizations who assume their Kubernetes environments are efficient enough, or they then don't have any concerns. What misconception or misconceptions would you correct first? What would you sort of make them focus on?
So one thing that is absolutely true, if you over provision, so you may spend too much compared to what you need. Sometimes you under provision memory. It's okay. It's normal, because it's just impossible to do by hand. And so this is one of the cases where automation, I would even say autonomous automation, meaning an automation that self-heal and organize itself, is a good thing. It makes our life much, much easier. You see, in this case, autonomous automation does not replace the human. It does the thing that us as humans cannot do anyway. And when you have this in the same sentence, we feel good about it. It's not an agent that replaces us. It's an agent that does the thing that we can do. And sometimes I meet our users and, team of 5 or 6 DevOps engineers that are managing this. And I tell them, you'll see, when you use agents and when you turn them on and make them autonomous, it will feel that you have 2,000 employees or 2,000 colleagues. because it really feels that way, because they are doing the thing that you couldn't do, and it makes your life a lot easier because now you have colleagues. They do the thing every second, they are obsessed with it, and they do exactly what you tell them to do. So they're like interns. You need to train them. You need to tell them, this one is very important. Make sure you have more resource than it needs. This one is a batch processor. It can use cheap machines. It's okay if it takes a bit longer, as long as it's inexpensive to run. You describe these, and we call them policies. You describe these as policies, and then you let those agents work within those policies, within those constraints, and they'll do the job that you can't. And they will help you become a better human because they'll do the things you couldn't do anyway. So that's a bit of message of hope, but we see that as a direct impact of using agentic framework.
Excellent. I mean, it's been fantastic to chat, and thank you so much for explaining in so many great details about the world that folks are getting to grips with, shall we say, when it comes to AI, Kubernetes, etc. So, Laurent, really appreciate your time. Thanks so much.
Thank you.